Now let's go ahead and get started, and we're still in 5.3. And now we're going to look at cubes. And for cubes, we have both a sum and we have a difference of cubes. And any of these formulas that you need are going to be on page 360. So they're all on page 360 at the bottom. And we're going to look at cubes. So for the cubes, we have a difference of cubes. And the difference of cubes is x cubed minus y cubed. And that is then x minus y and x squared plus xy plus y squared. Now, on these formulas, what is really important more than anything else is not the formula itself so much as the signs. Okay, so we got to make sure that we get the signs down. So that's a difference of cubes, and we also have a sum of cubes. And the sum of cubes is x cubed plus y cubed, and the signs are slightly different. So the signs for the sum go x plus y, x squared minus xy, and then a plus y squared. Okay, so these are our formulas. And again, the most important part with these formulas is going to be the signs. It's pretty easy to keep track of everything else, but the major difference is the signs. Now let's go ahead and make a short table of cubes, just like we did with squares. I think it's helpful to have a small table of cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed I believe is 64, 5 cubed is 125, 6 cubed I believe is 216. Let me double check and make sure. Yep, 216. And we'll go up to 12. So 7 cubed is 343. 8 cubed is, I believe, 512. Let me double check and make sure. Yep, 512. 9 cubed is 729. Let me double check and make sure. Yep, should be 729. 10 cubed is 1,000. 11 cubed is 1331. And 12 cubed is 1728. I think these are helpful, especially for the cubes, just to have the table of cubes, because it's going to be a common cube. Very rarely do you have a really large cube. It's normally going to be one of these cubes. Also, the exponents have to be divisible by 3. So also for cubes, the exponent has to be divisible by 3. Just like squares, it was divisible by 2, right? You had to split it in half. Cubes, you got to split it up 3 ways. And they're pretty easy once you just remember the signs and how the signs go. So let's do a real quick cube here. And we're going to try and factor this down. Let's try and factor, how about 343 z to the 9th power minus, we'll do a difference first. How about minus 27? Okay, now I know this is a cube, right? Because 343 is a perfect cube from our table. 27 is also a perfect cube. Now let's go back up and look at our signs for our difference of cubes. Here's how they go. They go minus, plus, plus. For a difference, it's minus, plus, plus. So we're going to do the same process that we did earlier. Minus, plus, plus. We take our 343, z to the 9th, and we're going to split this up 3 ways. So 343 again, if we look at our table of cubes, 343 by reversing out our table is 7. And then z to the 9th, well, that's divisible by 3. And that's going to be z cubed, and z cubed. Is everyone okay with that so far? What about the 27? That one's easy. 27 is 3, 3, and 3. Now, as we use the pieces, we're going to cross them off. So we start off with the 7z cubed. So that goes there. Okay, and that's gone. Now, what's left over? 7z cubed and another 7z cubed. So we multiply them together, and they're going to go there. Okay, so we got this one, which is here, and then whatever's left gets multiplied. So 7 times 7, that's a 49, right? Yes. Z to the 6th power. Gone and gone. Once we do a couple of these, it's pretty easy. What about the 27? 3, 3, and 3. So we've got 3. Okay, gone. 3 times 3 is a 9, goes on the end. The middle here is just those two put together. So 7 times 3 makes it a 21 z cubed. And that's it. Once we do several of them, it'll make sense. It's a pretty easy way of factoring these out. Let's try another one. And let's try to factor out, how about 64? P to the 6th plus, how about 7, or 729, let's do 729, z to the 12th. Okay, so first off, let's check. 64, going up to our table, perfect cube of 4. 729, perfect cube of 9, right? And p to the 6th, well, 6, is that divisible by 3? Yep. 12 is also divisible by 3. How do the signs go? This is a cube, and it's a sum. So let's go look at our signs here. Okay, for the sum. How do the signs go for the sum of cubes? Plus, minus, plus. See how the signs switch around? So this one goes for the sum, plus, minus, plus. And now we just fill it in exactly the same way we filled the last one in. So, first things first, 64. P to the 6th, we split that up. 64 was a perfect cube of 4. So that's 4, 4, and 4. And p squared, p squared, p squared. And then what about the 729? Well, 729, z to the 12th. If we go back and look, 729 is right here. And that's 9, right? So that's going to be splitting up 9, 9, and 9. Z to the 12th, well, that's Z to the 4th, Z to the 4th, and Z to the 4th, right? We split our 12 up 3 ways. Now we fill it in. 4p squared, gone. What's left over? 4 times 4, which is 16. That goes here, because you can check. 4 times 16, 64. That's what we want. P squared times p squared makes it p to the 4th. And you can always check. 4 times 4 is 4 times 16 is 64. 2 p's, 4 more makes it 6. So they're gone. Now we do the same thing with the 9z to the 4th. So 9z to the 4th here. Gone. 9 times 9 is 81. Z, and we've got 4, and 4 more makes it z to the 8th. What goes in the middle? Well, what's going to go in the middle is these two multiplied together. So it's just those two multiplied together. And 4 times 9 is 36. P squared, z to the 4th. And that's it. Students sometimes struggle a little bit more with cubes than with squares, just because it's a little more involved. But still, if you're careful, it's really not difficult to do these. Okay, let's do another one here. This one we're going to have to factor something out to begin with. So let's come up with something that we've got to factor out here. About 1029 z to the 13th power plus just making one up here. Okay, so that's 7. How about we do then plus, how about 1536? Yep, that'll be z. So 1536z there. Now, when I first see this, it doesn't look like those are cubes, does it? We need to make sure they're going to be cubes. So when we look, these don't have a 2 in common, but they're odd numbers. So let's see if a 3 is in common. And I know something's going to come out because we got a z there, right? And so I know at least a z will come out. I think these might have a 3 in common. Let's see, 1029, when we divide that by 3, that gives us 343. And we're in luck because 343 is a perfect cube. So we know we're on the right track. So I'm going to take out a 3 and a z. And when I take out this 3 and this z, that leaves me with 343 z to the 12th. Right? And then what about 1536? When I take a 3 out of that, I get 512. And that's another cube, isn't it? And now we also know we're on the right track because z to the 12th, remember, 12, my exponent, has to be divisible by 3. And it is. So now let's work these out over here. 343, z to the 12th. Well, 343 is 7s. So 7, 7, and 7. 12, divide that by 3, that's z to the 4th, z to the 4th, and z to the 4th. 5, 12 is 8. I'll slow down a bit so we can get caught up here. Okay, so we figured out that we had to factor that 3 out. We know it is a sum of cubes. So how do the signs go for the sum of cubes? Well, for the sum of cubes, you can look back at your formula if you need to. Sum of cubes, here's how I remember. It starts off with the sign, so it's plus, and then it switches, minus, plus. So the sum is plus, minus, plus. The difference is minus, plus, plus. It always ends in a plus, and the first piece is whatever you've got up here. So that's going to be 7 z to the 4th. Gone. What's left over? 7 times 7, which is 49. And 4 and 4 makes it z to the 8th. Gone and gone. And then we've got an 8. Gone. And 8 times 8 is 64. That goes on the end. And what goes in the middle? Those get multiplied together. So 7z to the 4th times that 8. Well, that comes out to be what? Okay, we've got 7 times 8. And that's going to be a 56. Z to the 4th in the middle. And there's your final answer. Let's do another one. And let's just do one more. Come up with a good cube here again. How about we try and factor 216 z to the 9th x to the 6th power, and let's do a minus. How about 343 y to the 12th? So no more difficult than any of the others. You just got to be careful with the exponents. That's the only difference. Okay, 216. Well, 216, if we go back and look, 216 is 6. So 216, z to the 9th, x to the 6th. What do? We take the cube of the number, right? And then we look at our variables. What do we do with our variables? Split them in 3s. So z to the 9th, 9 divided by 3 would be a 3. So that's z cubed, z cubed, z cubed. What about x to the 6th? Well, 6 divided by 3 is a 2. So that's z squared, x squared, and x squared. What about 343? Y to the 12th. 343, perfect cube of 7. 12 breaks down in 2. 12 divided by 3 is 4. So that's y to the 4th, y to the 4th, y to the 4th. Is everyone all right with that so far? Now, we know that this is a difference of cubes. So for a difference of cubes, the signs go minus, plus, plus. They always start off with the sign of the problem, which in this case is a minus, and then it switches, switch signs, and then it always, no matter what, ends with a positive. So differences are minus, plus, plus. Sums are plus, minus, plus. Okay, so we've got here 6 z cubed, x squared, gone. 6 times 6 is a 36. Z's, we've got 3 and 3 more, makes it z to the 6th. And x, as we've got 2 and 2 more, makes it x to the 4th. Gone and gone there. For the 343, we've got 7 y to the 4th. Gone. 7 times 7 is 49. 4 and 4 more makes it y to the 8th. Gone, gone. What goes in the middle is these two multiplied together. So 6z squared, sorry, z cubed. Make sure we got the right exponents here. So 6z cubed x squared times 7 y to the 4th. Well, 6 times 7, that's a 42. Z cubed x squared y to the 4th. I just picked this one and made this one up just because of all the exponents. We can also do this when we have a quantity, just like we did with squares. So we can do this with a quantity as well. So let's try and factor this one. These are a little bit more complicated just because all the pieces that we've got to work with. Well, first off, what do we have here? Well, we've got a cube, right? 8's a cube, and this is cubed as well. So let's go ahead and break this down. We've got z plus 5, quantity cubed. That's z plus 5. Z plus 5, Z plus 5, so there's 3 of those. And 8, well, 8's a perfect cube of 2, 2, and 2. They're a little bit trickier because you've got to keep track of all the pieces. And we're going to have to FOIL and combine things together as well. Now let's go ahead and write down what we've got. How do the signs go here? And leave yourself plenty of room for these. It's positive, so it goes plus, switches minus, plus. So z plus 5 goes there, gone. What's left over? Z plus 5 and another z plus 5. So that is z plus 5 quantity squared. Okay. Gone, gone. Then we've got our 2 from the 8, so that's 2, gone. 2 times 2 makes it 4 on the end. And what goes in the middle? What goes in the middle is those two multiplied together. So that's going to be 2 times z plus 5. Because that one and that one multiplied together. Now we've got to start the process of cleaning it up. So we're going to have to be distributing through. We're going to have to be foiling. We're going to have to be trying to combine things together as much as we can. So let's go ahead and work with our exponents first. So we need to clean this up. And we're going to clean this up by foiling. So we have a z plus 5 quantity squared. And that's z plus 5, z plus 5. And we're going to FOIL. And when we FOIL, that's z squared plus 5z plus 5z plus 25, which is then z squared plus 10z plus 25. And it's not difficult. It's just easy to make a mistake. And let's see what we can work with now. Okay, so on our first one, well, 5 and the 2, those can go together. Okay, so our first set of parentheses, we're going to condense that down into z plus 7. Because 5 plus 2 gives you the 7. For the second set, and you can use brackets or parentheses, it doesn't matter. I'm probably just going to use brackets so it doesn't look so confusing. So we took this and we FOILed it out. So that is z squared plus 10z plus 25. Okay, and for this piece here, we're going to have to distribute it through. And distributing that negative 2 through, that's going to give you a minus 2z. Remember, that's 5 there. And a minus 10. And then a plus 4. Almost done. This one just took a little bit of time because we had to clean it all up, rewrite things. Now we can combine everything that we possibly can inside of our square bracket, rewrite it, and we're finished. So out in front, we've got a z plus 7. In here, what can we combine together? Well, we've got a z squared. Nothing goes together with it, so that's it. But then what about the z's? For the z's, we've got a 10 and a minus 2. So 10 minus 2 makes it an 8z. Gone, gone. And then for numbers, we've got 25 minus 10, that's 15. And 15 plus 4 makes it then 19. And that is as far as you can possibly go. Okay, let's look at one more. And then that'll be it for today. Let's look at one. We haven't done much with 1,000, so let's look at 61. Just to make sure we remember how to do these. I'm not going to do another one of these because these are difficult. I only gave you one of them in your homework. So we're going to look at question 61. And this is on page 362. And we've got 27 minus 1,000 x to the 9. So this is what we're working with here. Okay, we know it's cubes, right? Because 27 is a cube, 1,000 is a cube. So 27 is 3, 3, 3. 1,000 is 10. Well, don't forget your x to the 9th. So we got 1,000 x to the 9th. So that's 10x cubed, 10x cubed, and 10x cubed, right? Okay, so we did that. That's the easy part. Now, what about the signs? How do the signs go? What's the sign in the middle? Negative. So how do they go? Remember, they switch back and forth. Negative, positive, and it always ends with a positive. And that's just the way that I remember. The sign comes down, and then it switches. So it's minus, plus, and it always ends in a plus. If it was a sum, it would be plus, minus, plus. You can either write it down, or you can just remember the kind of pattern that I use. So we know that 27 is 3's, so we've got 3, gone. 3 times 3 is 9, gone. And we've got the 10x cubed, gone. 10 times 10 is 100, cubed. Cube more makes it then x to the 6th, gone and gone. And then what goes in the middle is those two multiplied together. And that gives you then 30x cubed in the middle. Now I do have still some homework and some tests to hand back as well. So just before you leave, I'll double check and make sure you've got everything that turned back that's been graded. Should be able to do now your homework. You should be able to work through and finish up 5.2. You should be able to do them all. And 5.3, we can't quite do them all, but you can do all of them except, it looks like 11. You can't do 11 yet. Question 2. We'll learn about that one next time. And also 16. So you can do them all but 2, 11, and 16, it looks like. Because those we'll talk about them next time. But again, I do have some homework to pass back too. A lot of you picked up things last week.